We're going to jump into lesson 3.2, which is on surface area of prisms and cylinders. We'll start with a couple of definitions. We've got first the surface area. That's the total area of all of the faces. So that includes everything around the sides and the top and bottom. And then the lateral area is the sum of all the lateral faces. So that's everything except for the top and bottom. So the lateral area is just part of the surface area. Surface area includes everything. Lateral area, just everything around the sides there. Okay. So looking at the lateral area of a triangular prism, we've got a formula here, which is L equals P times H, where P stands for the perimeter of the base. And so when we're looking at this figure here, right, we know the base is a triangle. That's why it's a triangular prism. And to find the perimeter, we would just add up those three sides, A plus B plus C, and then multiply it by the height of that triangular prism, and we'd end up with the lateral area. And then we would take that lateral area and we'd have to add on the top and the bottom. So the area of these two triangles, right? Because it has a top and it has a bottom. So we'd have to add those two triangles, the area of those two triangles, to find the total surface area. And so they write it as P times H, which of course is around the sides, plus 2B, where this capital B stands for the area of the base. And since the base is a triangle, we know to find the area of a triangle, we do 1/2 base times height. And so that's what we would use to find the surface area. Let's take a look at one with some numbers here so we can start to put this together. First, I want to highlight that this is a triangular prism, right? Because the base is a triangle. All right. Of course, that's the same as the top, also a triangle. And so what's going to happen here is I'm going to need to find the perimeter of that triangle for part of my formula, but I can't find the perimeter of that triangle because I don't have all three sides. But I do know that this is a right angle here. They tell me that's a right angle. And so this is a right triangle. Let me go ahead and zoom in on that, where I have one side is 10, one side is 24, and we're missing the hypotenuse, which of course we label as C. And so I can go ahead and start to solve for that missing side using Pythagorean theorem. So I'm going to say 24 squared plus 10 squared equals C squared. And I'm going to go ahead and evaluate that. It's going to give me 676 equals C squared, right? I skipped a couple steps there for time. And then we'll go ahead and take the square root of both sides, and we end up with C equals 26. And so I'm going to fill that in as that missing side there, which is 26. All right. And so now it's going to allow me to solve for the lateral area here. So we have L equals P times H, where P is the perimeter of the base. Remember, the base is in the shape of a triangle, so I'm going to take the perimeter of that triangle, which would be 10 plus 24 plus 26, and multiply that by the height, which is 20. Okay. And then I can go ahead and evaluate that. It's going to give me 60 times 20, which gives me a grand total of 1,200 inches squared for the lateral area. Okay. And so what I did right there is I just found the lateral area. I want to quickly highlight what the lateral area is here so that you can see it really clear. It's the area around the sides here. So that would be this backside here, right on the left. Okay. And then the backside here on the right. And then also the front. Okay. And it's everything except for the top triangle and the bottom triangle. So we just have the parts around the side there. And now what we need to do is go ahead and find the whole surface area, which is going to include the top triangle and the bottom triangle areas. All right, so let's go ahead and do that. So we have that formula for the total surface area. So we have S equals P times H plus 2B, right? And we already know P times H, we just found that was 1,200. Okay, so we got 1,200 plus 2, and now I need to find the area of the base, and since the base is a triangle, that's going to be 1/2 base times height. All right, and then we can go ahead and find that, so that's going to be 1,200 plus 2 And then what we're using is this triangle right here, because that's what the base is, right? It's that triangle. And we know that the base of that triangle is 10, the height of that triangle is 24. So we've kind of zoomed in here to just that triangle on the bottom there, not looking at the entire 3D figure anymore, just looking at that triangle on the bottom. And so we end up here with 1/2 times 10 times 24. Okay, and then we can go ahead and evaluate that. So that's going to give me 1200 plus 2 times, let's see, that's going to be 120. And so then we're going to end up with 1200 plus 240. And that's going to give me a grand total of 1440. That's inches squared. All right. Okay, if you didn't totally get that one, we got one more shot. Let's take a look at this next one up here before you get to the homework. So we've got letter B, and again, it's a triangular prism. Now I want you to picture that this triangular prism has actually, it's been like pushed over on its side, right? Like somebody pushed it, tipped it over, because normally the triangles would be the top and the bottom, right? So we have to still consider that the triangles are the top and the bottom of this figure. It's just been kind of tipped over, like a block that's been tipped over. And for this one, it's nice because those triangles, we have all 3 dimensions, right? We've got the 12, 16, and 20. So then what I can do is just jump straight into my lateral area formula, which is P times H, where P stands for the perimeter of the base, and the perimeter of the base is the perimeter of the triangle, because the triangle should be the base. That'll always be the case. So I'm going to add up 12 plus 16 plus 20. And then times height, which is actually 14, even though it looks like it's laying on the ground, right? Remember, the triangles are the top and the bottom, so this thing has actually been pushed over sideways here. And so now I can go ahead and evaluate this here. So it's going to give me, let's see, 48 times 14. Okay, and I can go ahead and multiply those two together to get the lateral area, which would be 672. Okay, and so now we've got 672 as the lateral area. Remember, that's the first part of the surface area. And moving to the total surface area here, we've got the lateral area, so that's the first part of this. So I'm going to say S equals 672 plus 2 times B, big B, right, where that stands for the area of whatever the base is. In this case, the base is this triangle, so I need to find the area of that triangle, right, that 2-dimensional triangle. So I'm going to end up with S equals 672 plus 2 times 1/2, because it's a triangle, right? 1/2 base, and the base of that triangle is 16. The height of that triangle is 12. So we're just zoomed in on that part. And so then that ends up with 672 plus 2 times, let's see, that's going to be 96, right? Some quick mental math there. And then we can go ahead and add this all up. That's going to be a 672 plus 2 times 96, which gives me 192 for a grand total of 864. And that's just going to be units squared here because they didn't give me any units. All right, so now we're going to move to rectangular prisms. It's going to be the same formula as we used for above, except that there's going to be slight changes, because now when we look at the perimeter here, it's going to be a perimeter of a rectangle, so it'll have 4 sides. And when we look at the area of the base, so the big B here, it's going to be the area of a rectangle. So instead of 1/2 base times height, it's just going to be base times height, because the base is now a different shape than it was before. But the formulas still stay the same here, where we have the lateral area equals P times H, and we have the surface area, which is going to be P times H plus 2B, right? And of course, now the B has changed slightly, so the B, since the base is now a rectangle, is just going to be base times height, okay, or length times width. I can write it as length times width 2. That way we don't have too many overlapping variables here. okay, length times width, so that it's not no longer 1/2 base times height, because it's not a triangle anymore. Let's take a look with numbers here. So first, notice we've got the rectangular prism because the base is a rectangle. All right, so we know it's a rectangular prism where the base is a rectangle. So we can jump into finding the lateral area here. P times H. So to find the perimeter, remember, since it's a rectangle, I'm going to zoom it in here a little bit. We know that this opposite side is 8, and this opposite side over here is also 6, right? Because opposite sides are congruent there for the rectangle. And so I can go ahead and add those pieces up all together, right? 8 plus 6, and 8 plus 6 is going to give me 28. Times the height of this whole figure, which is 12, right? Okay, and then just some quick mental math there. 28 times 12 gives me 336 centimeters squared. And we've got the lateral area, so that would be everything around the sides, not including the top rectangle and the bottom rectangle, so kind of the base and the lid there. So let's go ahead and find those pieces here. So now we've got S equals, it's going to be 336 plus 2 times big B, where the big B is the area of the base. And this is a little bit easier in my opinion, right? Because it's just going to be 8 times 6, because it's just the area of that rectangle at the bottom. So that's going to give me 336 plus 2 times 48. Okay, and then I can go ahead and evaluate this, put it all together. I'll do it all in one step here, and we end up with a grand total of 432. And these are centimeters squared. All right, so we'll move to the next one here. Take a look at the lateral area of a cylinder now. So we're going to take a look at the lateral area of a cylinder. And again, we can use a formula for that. We've got, remember, the lateral area is just the parts around the side. That would just be kind of the rounded parts here. And the entire surface area would include the circle on the top and the circle on the bottom. So first, the lateral area here. Formula for the lateral area, L equals 2 pi r times h, right? Which would kind of just give me the area of what this rectangle is, which is what the net turns out to be. Okay, and so then we're going to end up with the surface area is going to be 2 pi r h, right? That's the lateral area, plus 2 of those circles, so 2 pi r squared. Right? Put these in parentheses so you can see that there are 2 circles there. So let's take a look here at the first one. We've got L equals 2 pi r h. Okay, so that's just going to be 2 pi times the radius, which is 3, times the height of this figure, which is 9, and that's just going to give me 54 pi. I'll leave it in terms of pi for now, and that's centimeters squared. And so then I'm going to go ahead and find the entire surface area. Okay, and so we'll just tack on the area of those circles here. So we got 54 pi, that's around the sides, plus 2 pi r squareds, right? And so then that's going to end up giving me 54 pi plus 2 times pi times 3 squared, and that's going to end up giving me 54 pi plus 18 pi for a grand total of 72 pi, and this is centimeters squared. And of course, if you need to evaluate to a decimal, you just do that on a calculator, right, or on Google, and you come up with your decimal answer there. All right, one more time here, same idea, except notice for this one that they did not give me the radius. They actually gave me the diameter, the whole entire line. The radius would, of course, just be half of that, so r is going to equal 2.5. Okay. And so then I can go ahead and find